Alright, so we have worked so far with rational expressions by finding the domain. We've reduced, we've multiplied and divided, we've added and subtracted, and we've even tackled those nasty complex fractions. Today we're going to be solving equations that have, let's keep it kind of short and sweet, that have rational expressions involved, and most importantly, along with the denominators that we have, there's x's in one or more of the fractions in the denominator. So maybe we have something short and sweet like 1 over x equals 2 over 3, and we're trying to solve this for x. One thing that's very important to keep in mind when we are working with rational expressions, anything from the first section in the book through the end of the chapter, is we have to worry about the domain. And we didn't use the word domain when we were adding and subtracting, when we were dealing with complex fractions, but when we're solving equations, it's a very important concept, something that we can't avoid and ignore and keep from dealing with. So when we're looking at the fractions that we have, if we set the bottom of our fraction, the only one that has an x in it, equal to 0, and we solve for x, it says x equals 0. And so remember, for the domain, we say, well, that's the number that I can't use. I can use anything else, but I can't use 0. And that doesn't affect or change the way we're actually going to solve this problem when we solve for x, but it affects whether or not we circle certain solutions when we're done. When we solve for x, if I find out x equals 9 or 12 or negative 13 or 14.7, those are all fine. But if I solve for x and it tells me x equals 0, I say, oops, I can't use that number. And so then I handle it accordingly. Okay. When I have fractions in an equation, whether the x's were on the bottom or whether they were just numbers like the 3 on the right side, okay, the preferred approach and the required one here is that we need to do something to get rid of all of those fractions. So if I look at the two fractions that I'm given, I have 1 over x and I have 2 over 3. Over here on the right where I doodled about the domain, I'm going to say I need an x and I need a 3 in my common denominator. So that lowest common denominator is 3x. What I'm not going to do is rewrite those two fractions as something over 3x. There is a way that you can take that path, but most of you get stuck in the middle and you're not sure what to do. Okay, so instead, okay, follow my path, okay, follow my lead, and what we're going to do instead is multiply both sides of the equation times that common denominator. What happens when we do that, if I've chosen the right denominator, and if I've multiplied correctly, then the denominators are going to go away, and what I have left on the left is 3 times 1, and on the right I have 2 times x, and what remains still will be an equation that has no more fractions in it, and is something that I know how to solve for x. So it's either linear, x to the first power, or it's quadratic, x squared, and I can factor. If I want to solve for x right here, all I have to do is divide both sides by 2, and I find out that x is equal to 3/2. Now, before I circle x equals 3/2, I take a peek up here at my list. I said, well, the number that I can't circle is 0. 0 is not the answer I got, which means 3/2 is completely and perfectly acceptable. If I'm going to approach a problem like this one, again, when I'm clicking through these, if you want to take a moment to pause the video to write down the problem, I would at least recommend that. If you want to try it without my help, go ahead and tackle that. And you can start it up along the way because I'm just gonna roll right through them. I'm gonna go in the same order every time, meaning first I'm gonna find the domain, and then I'm gonna go back and find the lowest common denominator. So again, on the bottom, if I set the denominators equal to 0, and I solve for x, okay, both 3x equals 0 and 5x equals 0 gives me x equals 0. So I say my domain again, is any number that I want except for 0. For my lowest common denominator, if I want to break down the 45 and go through the pieces like we did in the last section, we can. If we want to just go through the way that maybe we've always done it with numbers before I started messing with things earlier in the chapter, that's fine too. But 3 and 5 and 45, the lowest common denominator there is 45. And then I have an x over here and an x over here, and even though I don't have an x in the 45, I need an x to the first there on that lowest common denominator. So I'm going to multiply both sides of my equation times 45x. Got my x on the left. And understand that means that 45x gets multiplied by all of the pieces there. Okay, so not just the first one, not just the last one, every term. My x's are gone. 45 over 3 leaves a 15 on the left. So 15 times 2 is 30. If I take 45, and I'm going to go ahead and write the right side, 45x is 45 over 1. Okay, and some of you will need to do this. Okay, start seeing what goes away. And x's are gone. 45 over 5 leaves a 9. Here the 45s are gone. The x is still there. So on the right side, I have 54 plus 8x. A linear equation means I'm going to separate x terms from constant terms. And then I'm going to divide by that coefficient that's there. And again, before I circle -3 for x, I'm going to compare it to my list up there. I call that my no-no list sometimes. Okay, and -3 is not one of the numbers on that list, so it's safe to circle and say there's my solution. All right, I'm going to go ahead and stop this video here and start a new one that's got another 2 or 3 examples in it. So we'll pick up where we left off in the next.